Hi guys, how we doing? Welcome back to another video. So I've got a bit of an exciting one for you today, where I've got this fancy little motor kit that I've got from my employer. So as part of my job, this is a product that Matrix make, and I've been tasked with not upgrading the thing. This has been upgraded, so this is the second version of this DC motor coupling kit. So if I show you, I'll run it for you now. There you go. So this is the second version of it, and we have these curriculums. So I've got a electronics kit in front of me, and I've got like another two down there, and I've been tasked with basically going through the curriculums and figuring out what's changed on this. So some engineer has made some changes, or someone in purchasing has made some changes. I'm actually not quite sure. But whatever changes they've made, I'm going to go through the curriculum and figure out, does the curriculum need to be updated? So there's 3 different curriculums. The one I'm going through today, I believe, is called Automotive Motors, Generators and Charging Systems. So I think there's like 1 or 2 worksheets that, there's like a 15-page, do you know what, I'll just show you actually. There are 18 worksheets in total, and I think only 1 of them or 2 of them use this motor set. So we're going to go to that worksheet. This is the circuit for one of the worksheets, and I'm just going to test it basically, and I'm going to say, is the curriculum currently up to date or not? And I just figured it'd be a good opportunity for me to actually learn. So when I look at that, I can see that that's probably a FET. So I've got some PIC microcontroller, which is acting as an ECU, sitting in the middle here. I've got a potentiometer, which I can use to turn, so at zero ohms, I think this is off, which means, so this is controlling the PWM signal to that motor, and then as I crank it up, I'm essentially cranking up the PWM signal from I think like 0% up to 100%, something like that. Which I don't know what I'm doing yet. So I've got a FET here. If I look at this schematic, my negative of my motor is going to, I can't even remember what the FET things are. we'll go for it. Gate, maybe. So it's base, collector, emitter, transistor. What are the FETs? The MOSFETs. Gate. Damn, I can't remember. Anyways, yeah, we'll go through the curriculum and I'll relearn and reteach myself this, which is funny because I've got a very good video on MOSFETs, which is very popular and people like. So I should probably rewatch that video. Yeah, so I've got plus voltage going to this ECU thing, minus there, and then I've also got my 0 volts. Anyways, we'll figure it out. So let's jump into the curriculum and we'll go for it together. All right, cool. So here's the curriculum. Worksheet 9, the DC motor. So essentially what this curriculum, if I just scroll up to the top, it starts off with a vehicle's electrical system obtains energy from a combination of battery and alternator. The output of the alternator delivers electricity energy to peripheral units like headlamps and keeps the lead acid battery charged. This investigation uses an oscilloscope. Okay, so I should probably get my oscilloscope out. It uses an oscilloscope to study electricity generated when a magnet is dropped through a coil. Using an oscilloscope is a key. Okay, so yeah, I've got all this kit sitting on the floor next to me, which I'm not gonna go through the whole thing. It probably would be worthwhile for me to go through as a bit of a refresher, but yeah, I'm not gonna do that. So not right now. I've got way too much work to do. So the thing with I forgot most of this stuff since uni, obviously, because you don't really use it, but I guess the main thing about uni is that I could pick this back up within 5 minutes. So, the DC motor. Traditionally, the DC motors are the most common type found in vehicles. They use it. When I read this for the first time, I was like, huh? Really? But then obviously they just mean like all DC motors. So used for fans, windscreen wipers, electric seats. However, they're rapidly being replaced by brushless DC motors. So although I know there's a difference, I don't fully know that there's a difference right now. So apparently these brushless DC motors are more efficient and weigh less. The photograph shows a VW DC motor with an integrated gearbox. So that's that. So this is the circuit that I've built. Instead of using 2 electronics boards, basically these things, they ship. So I've received the kit as a brand new customer would. And this board is pristine, brand new. And they ship without these pillars, which is beyond frustrating because I had to install each one of these pillars, and I ended up just basically giving it to my wife and saying, please install these for me, and she did. So you got to like fit the pillar on, put the screw on, screw it on. So I'm not going to I'm going to try to not use two boards. If you see me with two boards later on, it's because I failed. But right now this circuit works. I can drive this motor. So this is the one board version of what you're looking at here, which is the two board version. So it just says build the circuit shown in the layout above, reset the micro ECU and use the up and down keys to select program 14. So I do that here on the screen. So if I reset it, pretty cool little microcontroller thingy. I'll pop this out for you actually and just show you what's inside it. It's pretty cool. So you got, can't really see much, but you got a PCB in there with a PIC microcontroller. The electronic guys at work, I mean, they're brilliant. They can do a lot with these sorts of things. So which way does this go in? Let's go this way. I'm really enjoying the whole electronics kit. The way it clicks in and clicks out is very nice. So if we press OK, oh, okay. So that's just running our output. So that motor's running now. All right, I don't want that. Can I go back? I guess it's reset. Okay. I'm gonna go up to 14. Yeah, man, let me in. All right, program 1, 17, 16, 14. It skipped 15 for some reason. All right, so DC motor control. Then I've got a percentage PWM, and so as I rotate my thing, you can see that percentage changing. There, all the way down to 0, and then if I go up to 30%, like the curriculum says, it doesn't move, but I guess I'm still pulsing it at 33%. So it's got a minimum in which it will move at, which appears to be 70. So at 16, 67 there, it started to move. I crank it down a bit. So it's still jittering at 67. 65. Doesn't move. Cool. All right. So what does it say here? Select the program, adjust the port until the display on the ECU shows an output drive of 30%. All right, so let's get it to 30%. Again, I'm just changing this pot here to 30%. Close enough? Oh, I did it. Nice. All right, so using an oscilloscope to view the output signal on terminal B. All right, let's set up my oscilloscope quickly. So, from what I can see, the curriculum says the output on terminal B, so that you got A, B there. So I take it this. Let's look at this circuit a bit more detail. So this microcontroller is outputting a PWM signal. So it receives the input on C, which is my potentiometer, my resistance, and then it's outputting on B, going, I guess, to the gate of the MOSFET. And then that's allowing current through. So I get 24 volts from here. So I get my 24 volt battery, but it's really a DC barrel, in here, into the motor, then coming out of the motor. And then so just like a transistor, it's just, this PWM signal is biasing the gate of the MOSFET, I believe. I should Google MOSFET quickly, but anyways, let's just say the gate for now. And then the signal, so my motor is coming through here, the 0 volts of my motor is connected to here, and then this MOSFET is allowing a path through to ground, which comes down here to here, and then back over to my 0 volts over here. So if I just connect one end of my one end of my oscilloscope to output B, at the other end to my 0 volts, then yeah, I can see a 30% PWM signal. Lovely. All right, so as I crank it up, you can see there. Is there anything better than a PWM signal? And you just love it. That's just cool. So if we look at the motor together now, we can get a much better display signal there. Cool, innit? All right, cool. I'm mesmerized. All right, let's carry on with this curriculum. So again, I'm still thinking in my head as I'm going through this, what if anything needs to be changed from the curriculum, which so far so good. So using an oscilloscope to view the output on terminal B, sketch the waveform on the graph paper showed in the student handout. Adjust the pot until the ECU displays shows an output of 70% and then do the same. So I think we're at 70% now. Okay. That's 70%. And the motor's like jittering. Okay. So now you get this part of the curriculum I like. So what? Typically, a 12-volt DC power supply uses PWM to vary the speed of DC motors in vehicles. A microcontroller in an ECU is used with a field effect transistor, so FET, to control this. Verifying the Mark-Space ratio, the width of the PWM pulse from a DC power supply has the same effects as varying DC voltage. It alters the average power delivered to the motor and as a result its speed. In motor circuits, FETs are used to sink current rather than supply current, i.e. they are used in a path from the motor to ground. Yep, so that's what we looked at. So motor, and then motor goes through the FET to go back to ground. The diode connected to the FET is called a suppression diode. Where's the diode? Ah, okay. So great thing about these components. So I'll pop this FET off. There's my MOSFET. And then I guess we've got a little custom made matrix PCB board here. And then that's a diode there. So R1, R2, D1. And so apparently this diode is called a suppression diode. When the FET turns off, the DC motor produces a positive back EMF spike, which is clamped at 12 volts by this diode, protecting the circuitry from high voltage. Okay. Is that a diode or a Zener? If it's clamped at 12 volts, is it a Zener diode? I don't know. The photograph below shows a dissected DC motor with the mains parts labeled. In the student handout, explain the function of the split ring and the carbon brushes. Oh, we're getting fancy here now. All right, so explain the function of the split ring and the carbon brushes. I can see the carbon brushes. Where's the split ring? Yeah, I don't know. So I'm assuming that earlier in the curriculum this has been taught, or yeah, I don't know, it's part of the automotive curriculum, and so therefore someone at this level of automotive would understand this level. I don't know. I kind of understand. I got a commutator, rotor windings, laminated iron rotor. Yep. Cool. So I just finished recording the video and I realized it was 40 minutes. So I'm going to interrupt this one here because I did one worksheet and then I did the next one. Well, I think it was worksheet 9, worksheet 10. Interrupt this one here. We'll end this video here and then I'll make the next worksheet into a separate video. And then hopefully you guys will see that. I end up whacking out this big oscilloscope and having some fun with the other motor. So yeah, you don't want to miss that. Cool. End this video here. See you in the next one. Take care. Bye-bye.